Yeah. Hello? I'm Matthew's your friend. Yes. Yeah, I use it's off, right? But hello. Hello. Oh, okay. After the class, I will open it again because it will make echo. Hello? Can you hear me? Maybe it came from your friend. Okay. Due to some device crashing. Yeah. Yeah. Free homework is already finished. Okay. Okay. The first question is, okay, the first exercise homework that you do is here, right? Determine the even and the odd part of the signal. Okay. The first step you must take is, yeah, right? XT is here. The first step in order to determine the even and the odd is you must determine what about transform? Time reversal first, right? Time reversal. Okay. You get time reversal to be the green cloud in here. Okay. Next one. The next step is, okay, yeah. You add between two signals, right? The same that I teach you, okay? The way to adding them, okay? You add each piece of the signal. For example, in this graph, you can see that you add 0 minus infinity to minus 3 first, one piece, right? And this piece is another one, okay? This piece is another one. This piece is the last one, okay? For this, okay, you add each point of them, right? Each point. When you add them, you add maybe, if you interest about in this zone, you add in this zone, a little bit left hand and a little bit right hand, okay? Okay, you add in them. The red one is here, for example. What about this point? This point equal to? Minus 1. This point equal to? Minus 1, right? The green equal to? Okay. Yeah. This point equal to? 1. This point equal to? 0, right? You add it there. Okay. Give you? 0. Give you minus 1, right? Okay. 0 is here, right? Minus 1 is on here, right? Okay, and then you get this piece of this part. Okay, each piece you add in there, split it. Try to do this. Okay, if you don't do them by yourself, I cannot help you. Okay, when the real exercise come or the real homework is come. Okay, or the real exam, you know that. Okay, you must do by yourself. Okay, yeah. See that? Okay, this part is about here. Okay, and don't forget to scale it by half, right? Scale by half. Yeah, yeah. 0, scale by half, give you 0, right? Minus 1, scale by half, give you minus 0.5. Okay, yeah. The red is part is here, okay? Now I will check you, okay? For you, everyone already finished it? Why you don't, anyone finish it? If you already finished, why you have? Okay, I will check that, okay? It's okay. Matching or not? Matching or not? When I told you, okay, to do is repeat. I will repeat it. Okay, you see that? It's not much question, right? Not much of work. I will give you 10 or 20, right? 2 or 3, right? If you, even though this, okay, this is a minimum exercise that you must do it in order to understand. Unless no one in the world can make you understand. Yeah? If you don't add by yourself, if you don't subtract by yourself, yeah, take the time transform by yourself. Yeah, you never understand it clearly. Even though you see maybe you listen the slide, listen the instructor very smooth one, right? Right, you see the maybe the movie. Yeah, you see the doctor do surgery square, right? Do you have the ability to surgery anyone? The same, right? You want to compute. Okay, the same. Okay, now if you do by yourself, almost all. Okay, if you do by yourself, you will check the answers. Okay, why? Right? Okay. Next step. This is for even part, right? For even part. For the odd part is the same, right? The odd part is here. Okay. Only one thing is different between the even and the odd. Okay, the odd, you subtract it, right? You use green red at the reference. Red at the reference. Okay, this minus 1, right? This minus 1, okay? The green equal to 1 and 0, right? Instead you adding them, you subtract them, right? Minus 1, subtract 0, give you minus 1. Okay, yeah. Okay. Minus 1 subtract 0, sorry. Minus 1 subtract 0 again, give you minus 1, right? And you, what about the minus 1? Minus 2 is about here, right? About here. And minus 1 is about here, right? Yeah? Okay. Yeah? And don't forget to scale by half. Scale by half. Yeah? Why? This is of the signal is here. Okay? For here, if you subtract, okay, follow my suggestions, okay? My advices, okay? Your final answer is here. Matching or not? Even though the signal is not difficult, it's a simple one, okay? But you must try to do it. The real signal in the exercise, in the exam, is not easy, okay? It's not too difficult, but it's more complex than this, okay? You must know how to do them, each piece of them. If you're not sure, it is separate them, okay? The way to separate the signal in each piece, okay? You see them, okay? Straight line. Okay, if the line is broken, if you change the slope or change the value suddenly, cut. You see that this slope equal to 0, right? And you change the slope and change the value suddenly, right? This point is broken, okay? Cut. This slope and this slope, in fact, is equal, right? The slope and the slope is equal, but you change the value suddenly, cut. Okay? Cut each piece, okay? We keep only the straight line, okay? Each process compute only for the straight line. Okay? Cut them and you compute each step. When you compute them, for example, when you compute in here, can it say you consider here? No, you consider a little bit point in this zone and a little bit point in this zone. We don't use the boundary because at the point you don't know. It may be 1, minus 1, or it may be 0, right? You're not sure. But if you move them a little bit, okay, you know that it's the point equal to minus 1 exactly. Yeah. I think it's okay. That's why it's okay to review the, because I don't have a Discord. It don't have so much time in the lecture time. Okay, you must help me. Okay, to take the exercise. When I order you to do, I really mean it. You can see that I give you 1 or 2 or 3. If you do by yourself, maybe 10 or 20 minutes. Okay. And one last thing. Okay, the thing that I order you to do is the minimum is mean. If you do that, you understand, Lamri? You pass. No, not yet. Okay. It's a minimum, okay? Exercise that make you understand. Okay, now, the second one, the second exercise, okay, the second small work, okay, is about here. Okay. The first one is here, okay? Now, xt is here. The first step you must determine time reversal. Okay, time reversal frame respect to vertical or horizontal? Vertical axis. Okay, vertical axis. Okay. After that, each is okay. Hot to cut in the same angle. Okay, same axis. Okay, and try to active each piece of that. See that? Okay. Now the first piece, second piece, third, fourth, fifth, and the last one. Yeah. Cut them in each piece. Okay, and you can add them. Yeah. The result, I think everyone already compute, right? You're waiting for the result. That you already add is correct or not? Okay? Yes, yeah. Matching or not? Matching or not? Matching or not? Okay. Không.คุณทำมันจะตรงไงเดี๋ยวอันนี้ตรงไหมอันนั้นแหละทีนึงคือลงท้ายใช่ไหมช่วยไม่ได้นะถามรุ่นพี่ก็เอาผมคือถ้าขี้เกียจขนาดนี้ใครก็ช่วยคุณไม่ได้นะครับเราไม่ทำเกียจใช่ไหมใช่ไหมตอบมาสิเดี๋ยวได้อะไรมาแล้วเดี๋ยววันเอ้าเกียจได้เลยไหมไม่รู้เลยเหรอเดี๋ยวดูดีสี่บวกไอ้เนี่ยในคำโจทย์เนี่ยมันไม่รอดนะเว้ยมันเก็บจริงๆนะถามรุ่นพี่เราคาถาอะไรตองได้ดีได้อย่างนี้เลยอยากได้ดีเหรอไม่ดีมั้ยใช่ไหมผมคงอยากได้ซีได้ดีกันนั่นแหละนะเพราะฉะนั้นตั้งใจนะถ้าครั้งหน้าไม่มาผมไม่ว่าเลยนะครับผมแค่มาร์กรายชื่อไว้เฉยแล้วถ้าคะแนนไฟนอลเราไม่ดีเนี่ยจะมาโทษผมไม่ได้นะพฤติกรรมคุณไม่ทำการบ้านไม่ทำอะไรเลยแล้วผมก็จะไม่คือที่ผมต้องจดรายชื่อเพราะว่าปกติถ้าเข้าห้องเนี่ยผมจะเขียนระบบก็คือถ้าเข้าห้องถ้าจะทำจดผมจะติ๊กนี่ผมโวไปเลยแต่เมื่อคุณไม่ทำไม่ส่งอะไรเลยคะแนนโอเวอร์คุณก็คือศูนย์นะครับ10 คะแนนจะเอาศูนย์ใช่ไหมนะนี่คือใจดีแล้วก็บอกว่าทำเป็น10 ข้อนะแต่ว่านี่คือแบบนะที่ทำแบบมินิมัมแล้ว2 ข้อพอตั้งใจทำเท่าที่ทำจะเอายังไงนะครั้งหน้าถ้าไม่ทำผมจะเริ่มจดรายชื่อนะรู้ว่าผมเซฟกับในแดนอยู่แล้วในแดนมาปั๊บทุกคนได้คะแนนเต็มเขาถือว่าเขาห้องมาทุกคนต้องทำงานแต่เยอะมากเลยนะเห็นที่เกียรติแต่ทำแรกแล้วไม่อยากเข้าไปบอกอาจารย์ท็อปเลยบอกพี่ขอเข้าเพื่อผมขอสอบไปมากกว่านี้เท่า1 เดียวเอาไหมได้นะผมก็สบายใจนะคือจะได้ไม่ต้องเหนื่อยสอนเพราะพวกที่เขาลงเนี่ยบางคนก็ลงรอบ2 รอบมาแล้วใช่ไหมรู้ว่าต้องตั้งใจทำนะพวกวิชามันไม่ได้ยากที่ผมมันยากที่การคำนวณอยู่แล้วตอนนี้คุณอาจจะมองถึงต้องบวกกันนิดเนี่ยเดี๋ยวอนาคตผมเริ่มยากจะปุ๊บยากไปเลยก็เลยแบบทำไม่ได้ถ้าครั้งหน้าไม่ทำผมจะเริ่มจดชื่อแล้วผมจะมาร์คแบบนี้นะแล้วคะแนนเก็บไปเป็น0 ตลอดจนกว่าจะเริ่มส่งแล้วก็เริ่มส่งมันไม่ได้หมายถึงปึ้งไม่ไปด้วยก่อนหน้านี้ที่ไม่ส่งเนี่ย2-3 อาทิตย์2 อาทิตย์3 อาทิตย์นี่ก็คือ0 หมดนะอยากให้เป็นอย่างนั้นตลอดเลยไหมตั้งใจทำนะเนี่ยทำมาผิดบ้างถูกบ้างอย่างน้อยมันจะรู้ว่าเนี่ยทำมาผิดไปหน่อยแต่ก็จะรู้ว่าผิดตรงไหนใช่ไหมคือพอคิดเองมันจะรู้ว่าไม่มีใครข้อที่ผิดได้มาฝากมาเอาเนี่ยเด็กซื้อก็ไม่เปิดสไลด์ก็ไม่เปิดนั่งดูบนสไลด์ชิวๆจะหลับไม่ได้นะตั้งใจทำดูรุ่นพี่แต่ละคนเนี่ยเตรียมตัวมาอย่างดีก็รู้ว่าโอเองเจ็บเองเหนื่อยเองนะดูอีก2 break all right นะ you do it not doing it นะ เปิดหน้าทฤษฎีสิใครเปิดหน้าหนังสือเขาหน่อยสิมันไม่เคยพอมีหนังสืออยู่ในนี้ก็ไม่เคยอ่านหนังสือทำไมสไลด์ขอไม่มีอยู่ในไหนสไลด์ก็เพิ่งไปแชร์ไปเสิร์ชสไลด์ครั้งแล้วแชร์ให้ไม่ได้ดาวน์โหลดไม่ได้ดาวน์โหลดใช่ไหมไปทำอะไรมาเข้าห้องไม่ใช่เหรอฮะมีอีกอันหนึ่งฟังเลย Okay. Some of you is asked me that, okay? Some student asked me, okay, why you multiply by 2? You don't know. Why the even part is divided by 2? What about is zero mean? Is zero mean that? He never read anything in the book. Right? If you read, you don't ask me. The same that you ask me, okay, why equal x is equal to x squared divided by 2? Right? Anyone equal x, okay, equal to x squared divided by 2? You have the question for this. When you get equal x equal to x squared. Why you don't ask me? Why equal? Why? It's a mathematical formula, right? It's already proved, right? The same. The even part of the signal is already equal to that, okay? If you don't know about that, okay? It means not only you not only you never read the book, but you never listen anything in the slide. They read and give you direction. Yeah? The even part equal to the signal, add with it, come reversal, and divide by 2. Where it came from? It came from here. Okay? The signal and it is reversal, right? Okay, give you here, you add between 2m. Okay? You can see that the first equation and the first equation is here, right? If you subtract between them, what happens? Okay? You add between them, okay? Add the first equation and the last equation. Okay? In the textbook, it's already proved in the detail, but in the slide, I think it's okay. It have a little bit of spread. You add them, what happens? You add between this equation and this equation, right? You add them, okay? This term and this term will be cancelled, right? What happened? Get x t, add with x minus t, right? Give you 2x et, right? And okay? Next time, okay? If you ask me, okay? Don't be shy. When you ask me, you will show me 2 things. One, the thing you don't know, and the thing that you exist to study. Okay? Right? It's already in the slide, and I think this slide already present one time before, right? Right? But when you take the exercise, you go home, maybe see the first day, and you never open the book, open the slide, read it again, right? And when you question, you remember only here, and you forgot here, you don't know why. Okay? For me, I have no problem, okay, if you ask me, okay? But I'm very disappointed on your, okay, about on your performance. Try to work hard a little bit. The exercise that they give you is a few, okay, you may read, okay, sacrifice only 30 minutes to read again. And the content of that is pretty good, right? I teach you only the even and the odd, right? So what's right? I think in the book maybe 2 pages. I understand that you think is okay, the best semester is just start, okay? You maybe have a time for raising, okay? No. When the time is Another 2 or 3 weeks after that. When we study about the convolution, about the other, we go far. Because the content of them will be based on the first 4 weeks lecture. You see that this one, your senior student works so hard. Not because of me, because he knows that okay, the content is difficult. So, if you don't prepare it well, okay, it's hard life. Okay? Now, we can back in here. Okay? Next time, when I order you to take the exercise, try to do it. Okay? If you don't know, okay, depend on you. Okay? Your grade is not you, it's you, belong to you. Okay? If you expect, okay, if you want to get A, it's you, right? Or if you don't want to get A, you want to get F, it's you. Okay? Not me. I cannot help anything. The thing that I help is here, right? I teach here, I can show the slide, and if you ask me, I can answer them step by step. Okay? Next time, okay? You can see that's what almost all do it. Okay? Maybe only 2 or 3 field that don't do it. Okay? And if you don't do it, okay, the next time I will give you maybe the list, okay? Because I assume that everyone is already in the agenda, and you get the full overall mark, okay? Only that list will be absent. Yeah. If you are so lazy, you can, okay, you may be cheating by maybe 2 minutes, okay, 3 minutes before the class starts. You duplicate from your friend. If you do that, okay, see that you suicide yourself. You don't understand anything, and when it's complex, okay, when the question is difficult at the time, you cannot learn that in time. You cannot catch up in time. Okay? Now we can back again. Okay? For you, I don't want to break anything so much because you already grown enough. I expect that. Right? It's like you do present and the equation is very simple, right? Integrate. Anyone integrate in here? Any point integration? Any point for differentiation? No, right? Only adding, subtracting, very simple. Adding and subtracting, I think you study in the grade 1, right? 0 add 1 give you 1. Okay? 1 add 2 give 2 in the mind. Okay? 1, 2 and 3 or something like that. Very easy. Not difficult yet. Okay? Now we will go to the next part. Okay? 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 The property of them, remember them. Okay? You the way to prove is not so very difficult. Okay? But you can remember them to use it. Okay? And the way to prove them, okay, is already in the question. Another 6 question in the exercise. Right? Another 6 question, okay? Yes, okay. The question number X to maybe 12, right? 12. Yeah. The way to prove them is okay, the same as the previous, okay? And okay, even and odd and the previous one. Okay? Is here. Wait a minute. Okay, we use about this thing. Okay, even and odd signal about them, okay, insert them and reverse as well. Yeah. Okay, is okay. Next one. The next one, the second property. The first property is already passed. The second property is periodic. Here, the signal is called periodic when it repeats. It repeats. Any waveform that it repeats. Okay? Why the periodic is very important in the engineering? Because if the signal is periodic, you can use several mathematics to express it. For example, I think everyone already studied past the Singularity, right? Singularity teach you the power series, Taylor series, or so on, right? If the signal is periodic, you can use the power series, Taylor series, or so on to model it. Cut them in one period and model it. Yeah? Express them in the Taylor series, power series. But in the engineering, okay, the Taylor series and the power series is rarely used. Almost all never sees the real application. Okay? We frequently use Fourier series instead. The Fourier series came from the transform, another one transform that you study from EE. Yeah. Okay, the Fourier series can apply indicate that if the signal is periodic. Yeah. In the engineering slide, you study only 3 transforms: Fourier series, Laplace series, Fourier series, and the Fourier transform. Laplace transform and set transform, only 3. Yeah. Fourier and the Laplace used for continuous. Yeah. Set transform used for the discrete or the digital. If you have a chance to study in the digital control, you use the Laplace transform to solve it. Yeah. If you study in only maybe the power supply, power transmission, system design, or something like that, we study only on Laplace transform. In the telecom and in electronics, concentrate on Fourier series and the Fourier transform. Yeah. Now, yeah, you can cut them. Okay. In this case, the signal, the period of them is very important. In this case, the signal have the period equal to 1 or 2 or 3, right? But the minimum period is 1. Okay? The shortest period in this case is 1, right? Cannot miss. 2 is still period, but not the shortest. Okay? The shortest is 1. Period equal to 1. And the shortest period is called the fundamental period. It's very important. Why? If you remember in the Fourier transform or the Fourier series, okay? The Fourier transform or the Fourier series, you must use the fundamental frequency to equate. If you use the wrong, your final answer is wrong. Okay? Now, in this case, okay, the continuous signal, we go to the signal will be equal to here. What are these transform? Time amplitude, time shifting, right? It means the signal, okay? If the signal is shifted by 1 period, okay, it's still identical. For example, it's a sine wave, right? If you shift them in 1 period, okay, it's still identical. You shift 1 period. But if you shift them less than 1 period, it's not identical, right? Okay? Therefore, the minimum period, okay, the shortest period that makes the signal is still identical, we call them fundamental period. The fundamental period. Okay? The signal equal to it time shifting. Okay? Okay? The continuous time functions that is not periodic, we call them aperiodic. And for the aperiodic signal, you know that if the signal is aperiodic, it means it has no pattern. Okay? You can apply the Fourier transform or the Laplace transform instead. Okay? And the fundamental period is mean the minimum value of the period t that make the signal shift still identical. Yeah? For example, here, if you shift by 2 pi, it's identical. But if you shift them by 0.5 pi, it's not. Yeah, it's not. Yeah. Next one, the unit. The unit. Okay. The period of the signal, the unit is second. Second. Yeah. You know that the time unit in the engineering is the second. Yeah. Therefore, the reverse of them, the frequency is unit of them is hertz. Yeah. But in engineering, the real application is not quickly used hertz. Here we use omega instead. The omega, the unit of them is radian per second. Okay? It's equal to 2 pi m. Okay? And the Fourier transform quickly use omega, right? Fourier transform, the Fourier series quickly use omega instead. Okay? Okay? In this case, T naught equal to fundamental period equal to 1 second, right? Or 1 hertz. Okay, 1 divided by 1 hertz. Okay. Omega equal to 2 pi m or 2 pi 1. Okay. Radian per second. Okay. Now, the real situation is about here. The signal that you must concern is okay, consider is a periodic or not, is here. You check it does. Okay. Yeah. Xt, okay, for example, x1 equal to here, x2 equal to this, okay. The questions are that the x1 and x2 is a periodic or not. Very easy. You check that the signal if it's shifting by t, okay. You can simplify them to be the original one. Okay, if you can simplify them to be the original one, it's still identical. It means the signal is periodic. Because sometimes the signal you cannot skip it. Okay, for example here, exponential sign. It's difficult to plot, right? Therefore, it's here t marginal. Okay, in this case, okay, if we assume that the signal is periodic, what will you get? You know that if the sign is periodic, you shift them by t, is still equal to sign, right? Sin t plus tau is still equal to t. Okay? Therefore, this term and this term, you can simplify them to be sin t because it's periodic, right? After you simplify them, you see them, okay? If sin t is here, it's still equal to the original one or not? Yes, right? Equal to the original one. Therefore, in this case, okay, x1, when you shift them, it's still identical to the original. This means the signal is periodic. Okay? But in another case, very close, okay? Okay, you can conclude that x1 is a periodic. But the second one is here. Okay? When you shift them, remember that you shift t, every t with capital T. Okay? Is here t, capital T. We are right. Okay, for here, sin t must be, yes, this term. You can simplify that to be sin t, right? Because it is periodic sign. But here, it's not. T must not be still. T must be, it's not equal to t, right? Therefore, it's still whole. Therefore, when you simplify here, this thing equal to this or not? No, right? You cannot simplify it. Therefore, in this case, this signal is a periodic. Yeah, when they give the signal, okay, you must check it first, okay? It don't use in this topic directly, but it used in the other application. For example, when they give the signal to you in the mathematical form, you must know how to analyze it. Sometimes you would like to apply the Fourier series. Before you apply the Fourier series, you must check it first. Hey, the signal is periodic or not, right? If it is aperiodic, you cannot apply Fourier series, right? You must apply Fourier transform instead. Yeah, if it's periodic or not, okay, you check it first. After you checking them, the more you know about the property of them, the more mathematics you can apply to them suitably. If the signal is periodic, you can apply the Fourier series, you can apply the power series, but you cannot apply the Laplace transform directly. Because the Laplace used for a periodic. Okay? Only special formula of the Laplace can apply on periodic, not always. Yeah? Yeah. Clear? Pure. Therefore, in this course, I teach you only two properties. One is even and odd. Another one is periodic. Only that. Okay? You know why we use it. Okay? You know, if you know the property is even or the odd, you can integrate them only half. Okay, reduce your complexity and easy for analyzing in the near future. Or if it's periodic or aperiodic, you know that you must apply Fourier transform or the Fourier series group, okay, to them collectively. But if you classify them wrong, nothing left. Because you violate, you broken the mathematics law, right? For example, when you try to apply the Fourier series on a periodic signal, you're wrong, right? You're wrong. Why? Because the Fourier series, you must integrate one period, but the signal, you cannot find the period of this, right? The period of the periodic is infinity. Yeah? Cannot do so. Okay, now. Okay, the next one, okay? The sum of the continuous time periodic function is a periodic if and only if the ratio of the periodic of the individual functions are ratio of integer as shown in the figures 1. Okay, it's here. Okay, psi periodic or not? Psi periodic or not? Periodic. Okay, psi 3 pi 2 pi periodic. Psi 3 pi is periodic or not? Periodic, right? Psi is periodic. Okay, and first one psi 2 pi. Okay, psi 3 pi periodic, right? When you add them, the result is, even though it's no longer psi, right? But it's still periodic, right? It will periodic because the period of them. Okay, the period of them, the ratio of each function is still in the rational. Okay, for example, the ratio of here is 2 by 3, right? You can write them in the rational number. What about the rational number? Okay, the rational number is mean 2 by 3. Okay, the integer and integer. You can write them to be the ratio of the integer. Okay, maybe 7 by 9 or something like that. Okay, it's not infinite floating point. Okay, if you can write them in the rational function, the rational number, it means the result is still periodic. Yeah, but in this case, you can see that this side, okay, 2 pi, and this side 2.5. The ratio of them is not right. 2.5 and 2 pi. Pi is irrational number, right? Even though somebody will, no, I need to study, okay, pi equal to 22 divided by 7. It's only approximation, not the real one, okay? It's not the real one, okay? Remember that? Therefore, in this case, when you add them, okay, the first term, side 2 pi is here. Side 2.5t is here. But when you add them, periodic or not? No, because the ratio is not rational. Yeah? Because in the real world, okay, when you analyze the signal, sometimes the signal is very complicated. You split them into where maybe 3 or 4 or trace sub-signal. Okay? When you would like to know that, okay, the overall signal is periodic or not, you analyze this term. Okay, this term is okay. You try to find the rational of all. Okay? If you write them in the integer of all, okay, it means the overall should be periodic. And if it's periodic, you can apply the Fourier transform or the power spectrum analysis to analyze. Yeah? Yeah? Okay, wait a minute. It is for solution of the, okay, the even and the odd part. Okay. The next one, okay? The next one is the common signal in the engineering, okay? What are the common signal in the engineering is mean the signal that you quickly try from the engineering experiment, or you maybe can see it in the oscilloscope, or maybe any scope, or maybe any computer simulation in engineering. Where is the signal came from? The signal came from the differential equations. They're from the differential equation. In general, almost physical system can be modeled by the ODE, or ordinary linear differential equation. Therefore, the solution of these ODEs, such as the input signal and the output signal, are usually the complex exponential form. Yeah, this is an example of the differential equation. Okay, we have the differential operator. Okay, A is variable in this case. What about the order of the signal? This equation. What about the order of them? First order, right? You see the maximum differentiated term, right? And the maximum is 1. Therefore, it's the first order. Yeah? The first order. Yeah? When you study in maybe, okay, you differentiate y respect to x, okay, but in this case, you differentiate x or f or anything respect to time. Yeah? Because this course will be make you closer to the real world, to the real physics world. Why? Differentiate respect to x. What about x? X is under rise. But t is time. T is time. Okay. Unit of time is second, not year. Okay. Even though your x is measured by year. Okay. But yeah, now get the solution. The solution in this case, the differential equation. Okay, the first order will be give you in the exponential. Only one exponential term. First order, you have only one term. Second order, you have 2 terms. 2. E, okay, E(A1t), E(A2t). Okay. Third order, you have 3 terms. Fourth order, you have 4 terms. Okay, you can see that if you have 25 order, you require 25 terms. You may have a question, why you must determine up to 25? in the real application. For example, when you launch the rocket from the surface socket to release the satellite. Okay, to release the satellite. It requires to at least y or at least the trajectory must precise. Okay, if you use lower than that, the accuracy is not enough. Therefore, the satellite that you launch may be fall by the gravity or maybe discussed to the gravities of the Earth, lost forever. Okay, therefore, 25, you cannot solve by hand, but you must know the idea to solve it. Okay? Okay? From the above equation and the mathematics analysis, okay, the parameters C and A, okay, C and A in this case can be real or can be complex, depending on the equation that you set. Okay? Okay? But in general, however, if the XC that you capture from the real world, is not real numbers, you cannot capture the imaginary signal. Every signal in the world that you record them, capture them is a real. But when you solve from the mathematics form, it may be complex. Okay? The same, the power, for example, in the electric power. You know that the unit of the electric power is P IV. Unit is watt. Yes. Everyone know that the watt that you measure is only real number, but it have imaginary power too. Imaginary power you must pay in the power factor form. Okay. When you study more, you will know that. Okay. Now, okay, we will concentrate on three cases. Okay, by the Euler equation. The E, okay, if in the complex exponential form, you can write them in the cos plus j sine, okay, right? So I think when you can study in the calculus 1, it's already true. Okay? Or you can write change from the cos and sine to be complex exponential 2. It is called the Euler's relation. It's usually used in the mathematical analysis of the complex exponential form. And typically, the Euler relation is used to convert between the complex exponential form and the triple. Okay? Yeah? You maybe convert the complex exponential to triple. Okay? The complexity form. And you maybe from the Euler relation, we can express the triple into the complex root. Okay? The complex exponential. Cos equal to here, right? When you study in E math, you frequently use here, right? Cos equal to E j. J is the square root minus 1. Okay, right introduced in the circuit before. Okay, we don't use I as square root minus 1. All engineering they will use this because I we frequently define the current. When you read I in the diagram, if you use here, you don't know I is represent for the current or represent for imaginary number. But in the engineering, okay, to make them prevent this confusion, okay, we just use J to be square root minus 1. Okay, I represent for the current, V represent for voltage. Okay, support. Okay. Now, sine and cos. Okay, three formula you can remember them, or you would like to prove you can do. Yeah, but you use them a lot in the mathematical analysis. Okay, the next one is here the XT can be CEAT in this case for the simple case. Okay, the simple case means if all C and A is a real number, Okay, if C is a real number, okay, A is positive, okay, A greater than 0 is mean it will be increasing exponential, right? Increasing. E2G, for example, E2G, E3G, E4G, increasing exponential. Okay, C is only constant to multiply them. If C equal to 1, okay, the exponential cut the axis at 1. Okay, and when it's raised to minus infinity, okay, C equal to 0. Okay, the exponential form. Okay, and the next one is here. If A equal to 0, anything power 0 give you 1, right? Anything power 0 give you 1 or give you constant. Okay, give you 1 or constant. right? Therefore, in this case, xt equal to c. Xt equal to c. Okay. Okay. If a is okay, if a is negative, okay. For example, e minus 2t decaying exponential, right? Decaying exponential. Yeah. The signal you can find from the oscilloscope or from the simulation program. Now, more. If C is negative. Now, if C is negative from the previous, if C is negative, what about the transform? Amplitude transform, right? It used to be increasing, therefore you frequency to vertical or horizontal. Right? Yeah. You see that the signal instead you okay is linked between each topic that I teach to you. Okay. The next one, okay, from the decreasing exponential, okay, is amplitude reversal, right? Amplitude reversal frequency to horizontal, okay, right? Okay. See that? And that's one. Okay. Okay. Yeah, the signal that you will see, okay? I don't know what about the pattern that you see. You maybe see one of these patterns, okay? Now, in some more complex case, for the some more complex case, in the case that C is a complex number and A is only imaginary, okay? If C is a complex, okay, C is complex, A is an imaginary. If A is imaginary, you can write them to be constant, right? Yes, B is constant, okay, V is real. Yeah, 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 yeah. You can see that, okay, it's imaginary J omega, and here is a complex. It's a complex unit, it's a complex exponential form. You can write it in the cos factor sum, right? So, yeah. Now, in this case, what about that from the complex exponential expression? Yeah, okay. You can group them, okay. For C, you go here, okay. A is here, okay. You can group that, okay. Is have some common J, right? Imaginary number, you can group there. EJ something. EJ something, you can use the Euler to convert them to be three-point, right? EJ theta. You see that? EJ theta equal to cos theta plus J sin theta, right? Okay, it's already in the book if you have it, okay? Yeah. By the Euler relations, the complex exponential can be expressed here. Yeah. Okay. From the above equation, the signal xt consists of both real part and the imaginary part. Yeah. In general, we plot the real. Yeah. Yeah. Cos this term plus k sine this term. Yeah. Now you can see that we have the real. This is the imaginary. Okay. If you would like to plot them, we plot both. Okay. If you plot both, what happens? Yeah. Okay. Cos function. The cos function. Okay. The cos start at the maximum, right, and drop. Okay. Cos start at the maximum and drop. Okay. From here. Okay. Drop. Right. Start at the maximum and drop. What about this phi? What about phi represent? What about this transform? Time or amplitude? Time shifting, right? Time shifting. That's why you shift a little bit left hand, right? Shift a little bit left hand. Yeah. Therefore, it's not in the center, right? It will be shifted by phi. Yeah, you will know where it came from. Okay. And the peak of cos is 1, right? The peak of cos is 1, but in this case, you normalize them, multiply them by a. Yeah, by a. Okay. The next one is, okay, is the sine, right? Sine. Sine start at the 0, right? Sine start at the 0. Yeah? Yeah? Start at the 0. But we have phi. What do we transform? Time shifting, right? Time shifting, therefore you shift a little bit. Therefore it's not pressed in the center. Exactly. Okay? Shift by this point and see there will be amplitude scaling. Okay, you amplify that to scale by it. Okay. Next one is you see that? The signal that you all see in here, that's why when you measure the scope, it gives you the sine wave. A lot of the sine wave you can find. Okay? Next one. For the last case is, okay, if C and A is a complex number. If C and A is a complex number, okay, yeah. Yeah, C is a complex exponential, is a complex number, and here is a real and imaginary part. Yeah, you can express them. Okay, substitute them in xg form. Okay, C substitute them in here, A substitute them in here, and in this case, you can grouping them. Okay, when you grouping them, you can observe that. Okay, this term is have j speed. This term have j omega, right? It's a common. Okay, you can grouping them. Okay, for this term, the decaying exponential or the decreasing exponential, we cannot do anything. Okay, but here, Ej theta again. Ej theta equal to cos theta plus j sine theta. Yes, we can use the Euler again. By the Euler relations, the complex exponential can express that following here. Okay, A E gamma T is fixed, right? Only this term. Yeah, omega t plus b is here, cos theta, j sine theta. Yeah, you plot it. When you plot in this scale, that from the whole equation, x consists of the both real part and the imaginary part. But in the generally, the real world, we have only real part. Okay, but we can plot both. Okay, for the magnetic analysis. Yeah, yeah. Now, cos, right? Cos start at the maximum, right? Cos start at the maximum and decreasing, right? And in this case, if gamma is greater than 0, it will be, the magnitude of them is not fixed, right? It will be increasing from in the exponential shape, okay? Therefore, when time increase, the magnitude of them is oscillate and decrease, okay? And the phi is represented for time shifting. Therefore, you shift a little bit. Okay? And in this case, you can see that in this case, amplitude scaling is not fixed, right? It's scaled by oscillation. Okay? Expand from time to time. Okay? That's why I'm going to teach you time and amplitude transform first. And why I teach you, I order you to do them to understand them. Okay? When you understand about them, when you do this, okay, you will understand. When you look at the signal, when you analyze the signal, you will understand them more deeper. Okay? Okay, next one. The green one is here, J is a sine start at center, right? Okay? Is here. If gamma is greater than 1, okay, the envelope of them or the amplitude of them will be increased from time to time. Okay, it oscillates and the magnitude of them will increase. Okay? Phi, time shifting, right? Shifting that make them not in the center. And A, E, gamma T is give you the amplitude scaling. But the amplitude scaling in this case is not fixed. Okay? It will be vary from time. When time increase, it increase too. But in this case, the signal you see that when time increase, it will be oscillate and about is unstable, right? Reach to infinite soon. Okay? Now in another case, okay, if gamma is negative, okay, if gamma is if gamma is negative, okay, the shape of this block will be if you decaying exponential step, yeah. The middle waveform is still cos function, yeah. This term is still cos function, yeah. Shifting by phi is yeah. The more signal you see in here, when you take the laboratory. When you see the signal, you don't think about it. Why you oscillate? Why it increase? Why it decrease? Okay, no. You know that no. It came from the magnetic equation. Why it here? It should be here. Yeah. Yeah. The green one is this. Yeah. 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 Decreasing. Yeah. Yeah. It starts from center. Yes, side. Yeah. Yeah. Envelope is decreasing. Yeah. Therefore, the magnitude overall will be increasing. When I'm increasing again, the magnitude will reach to 0. Yeah. And it has unshifted. Yeah. Now, in this case, You can see that the real signal you might analyze is not simple, right? It's not the rectangle, shifting, scaling easily. Okay, the real signal is a little bit more complicated. Okay, not complicated because of me. Okay, because of in the real applications, everything is not easy or simple like in the laboratory. Okay, you must prepare you to understand what the next step is. Okay. Okay. Next one is about the singularity. Okay. About the singularity is okay. What about the singularity meaning? I think you heard about the singularity at least one time. If it is a metric, right? What about the singularity meaning? Metrics, everyone know about them? Something like that, right? Not the metric moving, okay? That I heard that, okay, the part 4 will become after 20 years. Okay? Yeah, I will teach you another 5 minutes, okay, don't worry. Yeah. Now, what about singularity is here, right? Singularity. Okay? The singularity is mean, in the metric is mean, the thing that you cannot find, the metric you cannot find is inward. Right? The inward metric is here you may find transport and determinant of them or so on, right? Okay? You cannot find is inward. Okay? In fact, the singularity it have two meanings. Okay? The singularity is have two meanings. Okay? One in the physics world, another one in the mathematics world. Okay? I introduced them last week. The detail will be told you. Okay? In the matrix, okay, in the physics, okay, the physics, okay, the singularity is mean the situation that is that no law can apply, no physics law can apply. For example, the Big Bang. During the Big Bang or during the maybe the black hole situation, okay, because it's that situation, everything the math is so dead, okay, the gravity field is not spread like it usually be, okay. Every law, every physics law that the human know cannot apply. We call them the singularity situation. Okay? Or in the Hollywood movie, we figuratively found that the singularity figuratively represent for the situation because before it will become the supernova or the Big Bang or become the black hole. If anyone uses maybe 10 years before, Superman, the Man of Steel. Everyone knows Superman, right? Where he's born on the earth. He born at Krypton, right? Krypton. Okay? Krypton, yes. Okay? You know that, okay, he's a refugee, right? Okay? He's a refugee. Even though he already on the earth, but he has no visa. Right? No passport and no visa. Okay? Okay, now, for him, what happened? Okay? He is, okay? When you see the Man of Steel, maybe 10 years before, okay? You can see that, okay, some, okay? Maybe Kryptonian people, okay? Come, right? Try to conquer the earth, okay? The Superman go down, okay? Only one way to eliminate them all, okay? Because, okay, the main engines of this area is the phantom that maybe the black hole engine, okay? Therefore, he told that, okay, he have about the spaceship, okay, the refugee space, okay? They told them to be correct soon, okay? Become the black hole. When it's correct, okay, he told that, okay, the singularity will be exist. The singularity is mean the event that okay become black hole or supernova. And when it crash, it will be drained almost all Kryptonian people, right? Except Superman and another guy. Right? It's a guy that become the doomsday after in the second part. Okay? Okay? Now, in here, this singularity, okay, for the physics. Okay? When you listen to the Hollywood movie, you will know what about the singularity is. Okay? It means the situation that is have no physics law can apply, okay? And the singularity in the mathematics, okay, you know that okay, the singularity in the metric or the singularity in the function. It means the function or the signal that it have no derivative. Have no derivative. For example, here. Okay. Or in derivative equal to infinity. For example, this graph. The slope of this graph, the derivative of this graph, or the slope of this graph, right? The slope of them equal to 0, right? The slope of them equal to, what about this? 0? No. The slope equal to delta y divided by delta x approximately, right? Delta y equal to maybe 1, okay? Maybe 1 minus 0, right? Delta x, right? Equal to, right? Infinity. Therefore, we call this signal to be a singularity function. Okay? Means the function that have no derivative, or maybe have infinity derivative at some point. Okay? Even though it's not really exist in the signal in the world, but it's very important in the mathematical analysis. Okay? The time is almost end, therefore we could just stop here, okay? To give you time for transfer to another class. Okay? Good luck. Thank you for this. Okay, I will try to fix the microphones. Okay, soon. And don't forget to take the homework.